Some difference identities. Sum and difference identities are used to convert angles we aren't familiar with to ones we are, i.e. multiples of 30, 45, 60, and 90 degrees. For example, sine of 75 degrees can be written as sine of 45 degrees plus 30 degrees, but that is not equal to sine of 45 degrees plus sine of 30 degrees. Click the link below to see a proof of what sine of A plus B equals. While we could prove every one, sometimes it's a tedious process, so these are better to memorize. Cosine of A plus B equals cosine A cosine B minus sine A sine B. Cosine of A minus B equals cosine A cosine B plus sine A sine B. Sine of A plus B equals sine A cosine B plus sine B cosine A. Sine of A minus B equals sine A cosine B minus sine B cosine A. Tangent of A plus B equals tangent of A plus tangent of B over 1 minus tan A tan B. Tangent of A minus B equals tan A minus tan B over 1 plus tan A tan B. These problems put your factor and unit circle skills to good use. For example, let's find the exact value of cosine 75. Cosine 75 can be written as cosine of 45 plus 30. The cosine of A plus B is going to be cosine of A times cosine of B minus sine of A times sine of B. So we have cosine 45 cosine 30 minus sine 45 sine 30. The cosine of 45 is the square root of 2 over 2. Cosine of 30 is the square root of 3 over 2 minus the sine of 45, which is the square root of 2, times the sine of 30, which is 1/2. When you simplify, we get the square root of 6 minus the square root of 2 over 4. Find the exact value of sine pi over 12. Sine of pi over 12 is the same thing as sine of 3 pi over 12 minus 2 pi over 12. This becomes pi over 4, and this is pi over 6. So the sine of pi over 4 minus pi over 6 is sine of pi over 4 times cosine pi over 6 minus sine of pi over 6 times cosine pi over 4. So if we fill in all of those values, we can simplify and get the square root of 6 minus the square root of 2 over 4. As before, we can also use these identities to prove statements. For example, prove that tangent of x minus pi over 4 equals tangent of x minus 1 over tangent of x plus 1. Once again, begin with one side and simplify until it looks like the other side. You may need to use new identities. Alright, so we have tan of x minus pi over 4, so we can use our identity to write it out as tan x minus tan of pi over 4 over 1 plus tan x times tan pi over 4. Now tangent of pi over 4 is 1, so we can just cross that out, and now we have tan x minus 1 over 1 plus tan x. And then if you just reverse the order of the denominator, we have what is on the right side. So now they look exactly the same. Prove that cosine of x minus pi over 2 equals sine x. Alright, so we use the identity for cosine of A minus B, and that gives us cosine x times cosine of pi over 2 plus sine of x times sine of pi over 2. The cosine of pi over 2 is 0, and the sine of pi over 2 is 1. So that knocks this term out, and we are left with sine x equals sine x. Trig functions are unique because they're periodic. This creates a unique set of identities. Some horizontal transformations of trig functions will look like a parent trig function. Below is the graph sine x and one phase of two different transformations. We have sine of pi over 2 minus x and sine of pi minus x. Which transformation is exactly equal to the original parent function? Well, that would be this one in green. In the graph on the previous slide, the parent function sine x and its transformation sine of pi minus x seemed equal on the graph. Let's test this algebraically using our difference identity. Sine of pi minus x equals sine pi times cosine x minus cosine pi times sine x. Sine of pi is 0, cosine of pi is -1. When we simplify, we get that sine of pi minus x does equal sine x. Again, we could prove each of these, but now that we understand where they come from, we just need to know how to use them. All the identities are listed on the next slide. Here are the cofunction identities. Sine of pi over 2 minus x equals cosine x. Cosine of pi over 2 minus x equals sine x. Tangent of pi over 2 minus x equals cotangent x. Cotangent of pi over 2 minus x equals tangent x. Secant of pi over 2 minus x equals cosecant x, and cosecant of pi over 2 minus x equals secant x. And the supplement angle identities, sine of pi minus x equals sine x, cosecant of pi minus x equals cosecant x, cosine of pi minus x equals negative cosine x, secant of pi minus x equals negative secant x, tangent of pi minus x equals negative tangent of x, and cotangent of pi minus x equals negative cotangent of x. Prove that sine of pi over 2 minus x equals sine of pi over 2 plus x. Here we use our identity for sine of a minus b. That gives us sine of pi over 2 times cosine x minus cosine of pi over 2 times sine x. And on this side, we use our identity for sine of a plus b. That gives us sine of pi over 2 times cosine x plus cosine pi over 2 times sine x. The sine of pi over 2 is 1, the cosine of pi over 2 is 0, sine of pi over 2 is 1, and cosine of pi over 2 is 0. So that knocks these out, and we are left with cosine x equals cosine x. Sometimes it's best to rewrite both sides until they're equal.